Hello friend, this is the question number 56 in GATE Mathematics 2024 paper. Here, Jordan canonical form of a linear operator T in R4 is asked for, and four alternative choices are provided. We have to pick the correct choices. We will use in this question simple concepts like rank nullity theorem and the properties of Jordan block to establish the question. So these are the choices, and now we will start solving. Yeah, this is the question number 56. This says the T from R4 to R4 a linear map such that A only eigen values of T are 1 and 2. Second is dimension of T minus I and its kernel. Okay, this is 1. And third is the dimension of range of T minus 2I is 2. Okay, now let us analyze these two, and what we have to do, we have to find out what is the Jordan form of T. That is, what are the possible Jordan form of T. This is the question we have to answer. Yeah, so now let us answer this question. So 2 implies that kernel of T minus I is the set such that x T x equal to x, right? Or ideally it is T minus I x is 0, which is this only. Okay, T x equal to lambda. So, and this is nothing but the eigen space of eigenvalue 1. We denote it by E1. Okay, so dimension of E1 is 1. And now condition 3 implies, so here remember we are not given the dimension of kernel of that, but instead is range. So now use rank nullity theorem. Rank nullity theorem, what does it says? That if P is a linear operator from vector space V to vector space W, then dimension of B equal to dimension of range of P plus dimension of nullity of P. All right. So using this, now what is your P? Now you remember that T minus 2I is from R4 to R4, and keeping in view of this theorem, it follows that 4 equal to 2 plus dimension of null space of T minus 2I. All right. Why it is 2? Because this is the range of dimension of the range of T minus 2I, which is given in the question. Okay, so from here it follows that null space of T minus 2I null space of T minus 2I and its dimension is 2. So what does it means? This is nothing but E2. What is this? Eigen space corresponding to eigenvalue 2. So dimension of E2 is actually 2. All right. So now we can answer the question. So we have to pick those blocks from the choices for which we have 2 eigenvector corresponding to eigenvalue 2 and 1 eigenvector corresponding to eigenvalue 1. Now what are the choices? Choice A is given to you, and the choice A says that the choice A, if you refer to question back, you will find that it is given like this: 1, 2, and then 2, 2, 1, 0. And here it is 0, and this is a 0 block. and this is the 0 block. So finally, how many Jordan blocks it has? You see, this is one Jordan block, and therefore it has, okay, there is a result. I would like to refer you here. You can also prove, if time permits, I will prove sometime that one. But you remember that result, that they're always exist unique eigenvector, unique and only one. I mean, of course, unique eigenvector for each Jordan block. Okay, so given a Jordan block, you will get only one eigenvector. Of course, if the size of Jordan block is bigger than one, you will get an eigenvector, and rest of the vectors are the generalized eigenvectors. So that we are not right now talking. So at least, I mean, there is one eigenvector that exists. Okay, so this gives you one eigenvector, and this is another 1 cross 1 Jordan block, so this gives you one eigenvector, and this is 2 cross 2 eigenblocks, so this gives you one eigenvector. Of course, here you will get one generalized eigenvector also, but that we are not bothered. So total you have 2 here and 1 here. So this is precisely we want 2 eigenvectors for eigenvalue 2. Already we have obtained based on these 2 Jordan blocks, and one eigenvector corresponding to this block. We got it, so we are done. So this option is correct actually. Now what is the option B? Option B tells you that option B, if you look at it, tells you that 1 0 0 0, and there is one 3 by 3 Jordan block here, 1 1 0 and 0. So you see here, this is one Jordan block and this is one Jordan block. So you have one eigenvector and one from here. So of course you don't get 2 eigenvectors from it, because Jordan block will give you only one eigenvector. So there are two blocks, one is okay, but for 2 you are missing one eigenvector. Therefore this is the wrong answer. Now the answer number C. What is the choices for this one? It says it is 1 1 0 1 and 2 2 1 0 whole 0. These are the blocks. So here again you will get one eigenvector, and from here you will get one eigenvector. This is also wrong answer. Now what is the option number D? It tells you that 1 1 0 0 1, and yeah, after that you have 2 2, and this is 0 0, and this is all 0 block, this is all 0 block. So you see here you have one Jordan block, and you have one more Jordan block for 2 and one more Jordan block for 2. So total there are 2 1 cross 1 Jordan blocks. Okay, so one eigenvector from here and one from here, total 2 eigenvector. All right, so you got 2 eigenvector for eigenvalue 2, and you have a one eigenvector here for eigenvalue 1. So you are satisfying what you want. I mean, you need one eigenvector for eigenvalue 1 and 2 for 2. So this satisfies you. This is the right answer, because you expect that one. As per this one, we need 2 eigenvectors for E2, and E1 we need 1. So the correct answers are, if you look at the choices, correct answers are A and D. Alright, hope you have enjoyed this. You can refer in comments if you want, or ask any questions. Thank you.